Good evening. You're watching CNN. We come to you tonight with breaking news. Let's take you to our correspondent live at the scene.
Thank you so much. I am here live at the scene of the crime that took place just a few minutes ago. We are about to play some footage that we got from an eyewitness. Viewer discretion is advised. As you can see, there is a break in the footage, but what we do know is that homocysteine was walking down the transsulfuration pathway with serine when an enzyme came along and catalyzed a condensation reaction between the two to produce cystathionine and water, as pictured. Our prime suspect right now is the enzyme cystathionine beta synthase. All evidence collected at the scene is pointing to our current main suspect, cystathionine beta synthase. We hired a forensic sketch artist by the name of Jay Mole. Jay Mole was able to create this 3D rendering of our suspect. Cystathionine beta synthase, or CBS, is a homotetramer. 11 alpha helices, 7 short 310 helices, and 2 beta sheets consisting of 4 strands in the N-terminal domain and 6 strands in the C-terminal domain make up each monomer. The interaction between the monomers occurs in a parallel manner when the first additional beta strand interacts with the second beta strand of the C-terminal sheet of the other monomer. The center of the dimer interface is formed by the residues phenylalanine 44 on the A monomer and phenylalanine 44 of the B monomer. These residues are close to the dimer axis, therefore causing interactions between the two monomers. Deeply buried into the cleft between the N and C terminal domains is the coenzyme pyridoxal phosphate, or PLP. The active site for this enzyme is only accessible via a narrow channel. The cofactor is linked to the epsilon amino group of lysine 51 via a Schiff-based linking, forming what is referred to as internal aldimine. Now let's look at some possible motives. Why would the enzyme want to do this? Was it tired? Was it just made up of some amino acids? Or did it just need a snack? No, that can't be it. Was it murder? Oop, moving on. Let's find out what happens when homocysteine levels rise. Maybe that was it. Maybe he was just trying to help. Oh, what do we have here? When homocysteine levels rise in the body, it gives rise to a disease called homocysteinuria. Homocysteinuria can cause neurodevelopmental delays, lens dislocation, long limbs and stature, and lastly, it can lead to something very dangerous called thrombosis, or more commonly known as blood clots. Let's see what else we can find out. It's time for some cold, hard facts. So I pulled some strings down at the station to learn more about our pathway of interest. Ah, so CBS does have a record. It is known for this. I also see here that the end goal of this process is to convert homocysteine into cysteine. Okay, very interesting. CBS is also the rate-limiting enzyme in this pathway. What's this? Cystathionine beta synthase doesn't work alone? Aha! Jamal was right. It is working with the pyridoxal phosphate. It must be the coenzyme. These are all very interesting leads. As you can see, cystathionine beta synthase never rests, and neither will we till we get to the bottom of this. Back to you at the studio.
Thank you to our correspondent for that groundbreaking story. Thank you all for watching and have a good night.